Well, hello everybody. Hey, what I'd like to do with you today is first welcome you back. What a weird 2.5 weeks this has been. Run by our semester plans with you a little bit. Instead of overwhelming you today, I'm just going to give you a little bit of the information, and then watch your emails and watch Canvas to know the true plans of everything that's going on. What I'd like to do with you today is I would like to review everything that we've done so far in Chapter 8. Since it's been 2.5 weeks, that was our arithmetic sequences and series. I'll do that, guys, via a worksheet. If you're in my class, it's in Canvas, and I also send it to you via email. If you'd like to pause the video and go get that and print it off, you sure can. It's called Online 2020 Notes Class. And it's in our Canvas chapter in Chapter 8. So if you'd like to print those off and follow along, guys, I've got about 27 questions here. It's going to take a little bit. I hate for my videos to ever be over 30 minutes, but this one might be. But at least you can fast forward, listen, not listen. But what I'd like to do with you today is review with you our sequence and series items that we've done, kind of rehash some things out. There's an assignment that my class, I attached it via an email. It's also in the Canvas assignment bank. And then on the assignments in the very near future, and we will send you out a video for this also, we'd like for you to save them as a PDF. So with your phone, take a picture of them, download a PDF maker, and then that way you could upload them into Canvas for us. That's how we'd like to handle things the best. If you're struggling with that, just make sure you get it to us. Take a picture of it and send it in via email. Next week, what we're going to do is review sheet with you and then test you the following week over our Chapter 8 items. But I'm going to jump right into these, guys. After this, we start more trig. I hate to do trig online because I love to see that panic in your eyes on how to do some trig proofs, but we'll hash through that. So if you would, jump over to your class examples that look like this. Guys, I'm going to review the whole Chapter 8. Now, keep this in mind. Tests and quizzes, they are now open notes for obvious reasons. We talked about trying to do Zoom conferences while you take your tests, and we were going to watch you like a hawk, and we just decided that's not worth our time or our effort. So, tests and quizzes, open notes. So do a good job with this. It'll pay dividends for you in the very near future. So, come over to your first one. I'll review Section 8.1 and 8-2 with you. Those are the two sections that we did after the last test, so that's been a while. Now, guys, to list the first 5 terms, there's a number of ways to do these, but all you need to do is plug in 1 to get the first term, 2 to get the second term, 3 to get the third, fourth, and fifth. So, guys, the first 5 terms of this, when I plug in a 1, 3 times 1 is 3, plus 7, my first term is 10. Plug in a 2. 2 times 3 is 6, plus 7 is 13. Plug in a 3. 3 times 3 is 9. 9 plus 7 is 16. Take my word for it, when you plug in 4 and 5, you're going to get 19 and 22. Trip down memory lane. This is called an arithmetic sequence. Arithmetic because we are adding or subtracting the same number every time. A sequence because this term is separated by commas. In no word in there was there the word sum. Now, number 2, to plug in to get your first 5 terms, same thing, 1, 2, 3, 4, 5. Plug in a 1. 1 minus 1 is 0. 2 to the 0 is 1. 1 times 3 is, my first term is 3. Now let's plug in a 2. 2 minus 1 is 1. 2 to the first is 2. Times 3 is 6. Plug in a 3. 3 squared, or 3 minus 1 is 2. 2 squared is 4. Times 3 is 12. And then our next 2 terms will be 24 and 48. Now, guys, this one's called geometric because I am multiplying by 2 every time. I'm multiplying by 2 every time. And both of these are explicit because to get your terms, you just had to plug in 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now, number 3 is just a little bit different. This is called a recursive formula. So in this case, you were told what your first term is. My first term is 9. My second term, don't let the notation confuse you. This really says your second term is your first term plus 6. So now when I add my 6 to that, looks like I'm going to get 15. Need the third term? This now says my third term is my second term plus 6. So we're just adding 6 each time. So there's section 8-1 so far. There's 1, 2, and 3. Pause the video if you need to write anything down, if I get going too quick for you anything. Now number 4, you have a note card with some formulas on there. I'll review those formulas with you as we go today. If you don't have that note card, it's at school or in your book bag and lost forever, write some notes as you go today. I've already cheated and wrote down some important formulas. So number 4, given the sequence 5, 11, 17, 23, write a formula that will generate the nth term and then find the 100th term. Well, where I need to start is I need to notice that this is arithmetic. Arithmetic because I'm adding 6 every time. So in this case, my D value happens to be 6. Now on your note card, you have a formula that looks like that. We might have put the D in the back, but that really won't matter. So here comes the formula, guys. I'm going to go a sub n equal a sub 1, which happens to be the value of my first term, which happens to be 5, plus 6, that's my D value, we're increasing by 6 each time, n minus 1. Now I'm just going to simplify this formula. 5 plus 6n minus 6, so my formula is 6n minus 1. Never miss these, especially on a test or quiz. To make sure you're right, to check it, plug in a 1 and make sure you get 5. 6 times 1 is 6, minus 1 is 5. Plug in a 2. 6 times 2 is 12. 12 minus 1 is 11. I know this formula is 100% correct. Now, to find the value of the 100th term, I'm just going to plug in 100 into that formula and get 599. Notice how I pick numbers that I can do in my head without having to touch my calculator. So there's my first number 4. Here's my number 5. Given the sequence 12, 7, 2, negative 3, write a formula, and then state which term has a value of 408. Well, let's go get our formula first. It's arithmetic again. So let's go. A sub n equal, maybe, 12. Now guys, in this case, my D value happens to be negative 5. So let's go minus 5, n minus 1. Let's simplify this. So I got 12 minus 5n plus 5. So my formula looks like negative 5n plus 17. And then once again, we could check it to make sure it's right by plugging in 1 and 2 and 3. Now let's bring home part B. Which term has a value of 408, negative 408? I'm going to now take my formula, negative 5n plus 17, and set that equal to negative 408. If you subtract 17 and divide by negative 5, you'll get the 85th term. So there's a couple of arithmetics for you. Now let's look at a couple of geometric. On number 6 it says, given the sequence 2, negative 6, 18, write a formula that will generate the nth term and then find the value of the 10th term. Well, here's a formula that deals with the geometric sequence, a geometric sequence. Geometrics are nice to work with. Watch how easy they are. I've got g sub n equal. My g sub 1 is my first term, which happens to be 2. Now I need my r value. In this case, guys, you can just look at it. We're multiplying by negative 3 each time. If you can't look at it, on your note card is a formula of how to get your r value. It's your second term divided by your first term, or your third term divided by your second term, or kind of on down the road. And then n minus 1. There's my formula. Now to find the value of the 10th term, let's go 2 times negative 3 and raise that to the 10 minus 1, which is 9. And if you run that through your calculator, negative 39,366. Now guys, also on that, we don't miss these. Like I said, we don't miss these because check out what you can do in your calculator. I can type a 2 in and hit enter. That way it's in the calculator's data bank. Now, each time we're multiplying by negative 3, so let's go times negative 3. There's my second term. There's my third term. 4th, 5th, 6th, 7th, 8th, and my 9th, and my 10th. So 2 ways to get that answer. 1, via the formula. 2, just kind of looking at it. Now, while I got my calculator out here on number 7, let's look at that and see if we think that's arithmetic or geometric. 4 plus 2 is 6, but if I add 2 again, I do not get to 9. So it's probably geometric. To get my R value, let's go 6 divided by 4. So I believe I'm multiplying by 1.5 each time. Well, let's do this problem twice. Let's kind of do it the easy way first. I'm trying to figure out which term has that value, 153 point. Well, let's go ahead and go 4, enter. Let's multiply by 1.5. There's my second term. There's my third term. There's the 4th, 5th, 6th, 7th, 8th, 9th, 10th. So it looks like this is going to be the 10th term. Now let's put it all together. My formula, G sub n equal 4 times 1.5 to the n minus 1. And in this case, that represents the 10th term. Now guys, if we were in class and we were together, I would remind you how to solve this thing by using logarithms. We'd set that formula equal to that number and solve it via logarithms. Since we're not together, I decided to just show you the quickest and easiest way. Now, here's your number 8. Decided the following sequences. Guys, I underline that word because we had confusion before if something had a limit, if something didn't, if the series had a limit, if something didn't. A sequence, you're just looking at what the ending number's looking like. As you go to the right forever, what's that number approaching? Now, little notes, and this is on your note cards, if it's geometric, if the sequence is geometric and your R value is less than 1, the absolute value of R value is less than 1, then it will converge. Now check out what's happening here. It looks like we're multiplying by 1/2 every time. Well, if you keep multiplying by 1/2 forever, guys, this number is going to get smaller and smaller and smaller. So this is going to converge. And it's going to have a limit of 0. If you needed to play with your calculator a little bit, you could hit 8, enter, times 1/2, enter, 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 and you would see that number get smaller and smaller and smaller. Here's my number 9. It looks geometric. 12 divided by 8 is 1.5. 12 times 1.5 is 18, so this is geometric. But now in this case, my R value is 1.5. Since my R value is not less than 1, this diverges. Also means that the limit does not exist. My number 10, if you look at it, this is geometric. My R value is going to be 1/3. If you keep multiplying forever again, this will converge. and it will converge to 0. Now, if you want to kind of see it again though, if you plug in a 1 to generate your first term, 1 minus 1 is 0. 1/3 to the 0 is 1 times 4. My first term is 4. My second term will be 4/3. My third term would be 4/9. I'm going to multiply by 1/3 forever. Well, check out what your number's doing. Getting smaller and smaller and smaller. Now, peek at your number 11 real fast. It's a different little sequence. It's not arithmetic, and it's not geometric. We're going to go -4 to -2, -2 to -4/3, down to -1. This part looks really confusing. But whenever you're given a formula, it's really going to be an easy problem. Because just by looking at it, you can tell if it converges or diverges. We have 3 different scenarios, and I'm going to hit each scenario with you between 11 and 12 and 13 and 14. Now, think about this. Focus on the -4 over n. Since my biggest power is in the denominator, as n goes from 1 to 2 to 3 to 10 to 100 to 1,000, this number itself will get smaller. So this is going to converge, and it will have a limit of 0. Now, the other cases, while I got you here, let's peek at number 12. To be truthful, these numbers don't really matter. How did I get them? I plugged in 1, then I plugged in 2, then I plugged in 3, but this is where my main focus is. 2n plus 1 over 3n plus 5. I want you to notice this. The highest power in the numerator is this first degree for the n. The highest power in the denominator is also a first for the n. Since the highest power in the numerator is equal to the highest power in the denominator, our limit is just this coefficient. So this converges, and it converges to 2/3. Now, I'm going to drop down to number 14. Look at it. Notice that there's no numbers. No big deal. Look at where your highest power is. In this case, my highest power is in the denominator. That means as n goes to infinity, the denominator is going to grow a lot faster than the numerator. So this will converge, and it'll have a limit of 0. Let me say that again. Whenever the biggest power is in the denominator, it will go to 0. What happens if the biggest power is in the numerator, like it is on number 15? This limit does not exist. This will diverge. It'll either grow forever, or it'll either go higher, higher, higher forever, or lower, lower, lower forever. Now, let's come back up to number 13. Number 13, if you think about it, let's show you the first few terms. When I plug in a 1, 12 minus 2 is 10, so my first term is 10. Let's plug in a 2. 12 minus 4 happens to be 8. Let's say all that again. When I plugged in a 1, I got 2. When I plugged in a 2, I'm going to get an 8. When I plug in a 3, I'm going to get 12 minus 6. When I plug in a 4, I'm going to get 12 minus 8, so I'm going to get 4. Notice, so this is going to go down forever. It's arithmetic. It's arithmetic. So this is going to diverge, meaning the limit does not exist. So guys, in the formulas, just remember, highest power in the denominator, it's going to converge to 0. If it's a tie, like it is right, where's my tie at? If it's a tie like it is on number 12, this will be your limit. Also your horizontal asymptotes. Now, while we're in chapter 8, in section 8.4 and 8.5, we talked about series. Now, some more formulas that you should have written down or you should have on your note card, I've listed them right here. This S of n equal n over 2 times a sub 1 plus a sub n, that formula is an arithmetic series formula. And if you remember the story, that's little Carl Gauss who invented it. This formula right here is a geometric series formula. Now guys, make sure that it's a series when we do these. To know it's a series, you're going to see plus signs in between each terms, or I guess you could see minus signs, and you'll traditionally see a sigma sign. You just got to decide which kind it is. So number 16 is going to look like this. We are going to sum up the first 100 terms, the first term, the second term, the third term, all the way to 100. Well, I'm going to use this formula right here. So to get the sum of these 100 terms, I'm going to go 100 divided by 2. Now, along the way, I need a sub 1 and I need a of 100. Well, to generate a sub 1, let's plug in 1 into here. 3 times 1 is 3. 3 minus 1 is 2. Let's go figure out a sub 100. So a sub 100 is going to be 3 times 100 minus 1. So a sub 100 is 299. Now to get our sum of the series, 100 over 2, a sub 1 plus a sub 100. And then we will just run that through our calculator. If you want to make sure you're running things through your calculator correctly, you should get a total of 15,050. Now, number 17, you got to recognize it first so you know which kind of formula you use. Anytime it's written like that, it's going to be geometric. And since there's that Greek letter sigma, we know we're summing them up. So this is going to look like this. The sum of these 12 terms is going to be, I need g sub 1. So let's plug in 1. 1 minus 1 is 0. 3 to the 0 is 1. Times 2 is 2. And then I've got 1 minus my r value, which happens to be 3, to the 12th power, over, and then put this in parentheses so you don't mess it up, 1 minus 3. Now guys, you might grab your calculator and make sure that you know how to run this through correctly. Type in it exactly the way you have it, 2 parentheses 1 minus 3 to the 12th, divided by parentheses 1 minus 3, and you should get 531,440. Here goes my number 18. We got 4, 7 plus 10, dot, 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 to 181. Now, this one's a tad different. I know my a sub 1 term is 4. I know my last term is 181, but I do not know how many terms there are. I do know that my d value happens to be 3. So we need to figure out how many terms there are. You got a couple of options here. You could type in 4 into your calculator and go plus 3, enter, 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 enter until you get to 181. Or we could generate a formula first. So I'm going to do this. I'm going to say g sub n equal, I'm going back to that g sub 1 plus d n minus 1 formula, is going to be 4 plus 3 n minus 1, and we're going to solve this thing for n. So g sub n happens to be 181. I've got 4 plus 3n minus 3. I've got 181 equal 3n plus 1. If we solve this, it looks like n is going to be 60. Now that is not my answer. that means that there's 60 terms. To go get the sum of these 60 terms, it's now going to look like this. 60 divided by 2, a sub 1 plus a sub 60. So there's what it looks like there. And then when we run that through, we should get 5,550. But the key there was I recognize it as arithmetic. Or number 19, I'm hoping that you recognize it as geometric. What makes it geometric? That right there, and that n minus 1. So things that I know and need, I need g sub 1. So let's plug in 1. 1 minus 1 is 0. 3/4 to the 0 is 1. Times 28 is 28. So g sub 1 is 28. My r value is 3/4 or 0.75. I'm going to use 0.75 because that's easier when I run this through my calculator. So the sum of these 20 numbers is going to be g sub 1, which is 28, 1 minus 0.75 to the 20th, all over 1 minus 0.75. And guys, if you want to make sure you can run that through correctly, that's going to be about 111.64. So that's geometric sequences, sorry about that, geometric series and arithmetic series. That was section 8.4 and 8.5. Now, some of you have seen this material and some of you haven't. The last section in chapter 8 talks about infinite series. My class had seen it, the Maroon Day. Miss Dinahan's Maroon Day should have seen it. Your Gold Days haven't yet. It's really a simple concept. So I'm going to go ahead and roll through it. And there is some calculator work I need to show you on a couple of these. So here goes your number 20. State whether the following infinite series is convergent or divergent. If the series is convergent, give its sum. Now make sure you understand what's going on here. This is a series, which means we're going to add these up. So some things that I know, my answer is bigger than 18. My answer is bigger than 18 plus 9, which is 27. My answer is bigger than 27 plus 4.5. So I know my answer is bigger than 31.5. We are going to add these forever. Now, we had a little shortcut, and I kind of scribbled that off to the side over there. But number 1, if it's geometric, and number 2, if your r value is less than 1, the absolute value of r is less than 1, then it will converge. To get the number that it will converge to, we have this handy little formula. The sum, as we go to infinity, is going to be g sub 1 over 1 minus your r value. So here goes number 20. It's definitely geometric because we're multiplying by 1/2 every time. My r value is less than 1. So this will converge. What will it converge to? 18 over 1 minus 1/2, which is really 18 over 1/2, which converges to about 36. That's all there is to it if it's an infinite series. But be careful. Make sure that these criteria hold. Here's my number 21. It's definitely geometric, so we take care of that. My r value happens to be 3/4. So it's geometric. My r value is 3/4. The absolute value of r is less than 1, so this thing will converge. So the sum, as we go to infinity, is going to be g sub 1. So let's go get g sub 1. 1 minus 1 is 0. 3/4 to the 0 is 1 times 28 is 28. So I've got 28 over 1 minus 0.75, 3/4. If we run that through your calculator, this is going to converge to about 112. So that's how we handle it if it's an infinite series. Here's number 22. We'll kind of click through this. Number 1, is it geometric? Yes, because of that 1/2 in there. Now, be careful here. My R value is 1/2. So there's part 2 of my criteria. So this will converge. Now make sure you correctly find your first term. On the other 2 examples, it happened to just be the first number. This isn't the case on this one. If I can get back to it. There we go. To get g sub 1, let's plug in 1. 1/2 to the first is 1/2. 1/2 times 16 is 8. So now the sum as we go to infinity is going to be 8 over 1 minus 1/2. So this will converge to approximately 16. My 23, we need to decide 1, is it geometric? So to find out if this is geometric, let's check your R values. If I look at 6 divided by 5, I'm going to get 1.2. If I look at 7.2 divided by 6, I also get 1.2. So it definitely looks geometric. Now my R value then happens to be 1.2. In this case, my R value is not less than 1. So this does not converge. In this case, it's going to grow forever. So this diverges. The limit does not exist. Here's my number 24. Be careful. 5 plus 8 plus 11 plus 14. Guys, when you look at this one, we are adding 3 every time. So this is arithmetic. As soon as it's arithmetic, it diverges. So the limit does not exist. Let's get that better. Now, I'm going to slow down on 25 and 26. There's some calculator work here, guys, that I need to walk you through. So before we start, pause the video and write down these steps if you would. Because we haven't done anything like this. I ran out of time in my classes. Hopefully Ms. Dinahan got to it. But I want to show you how we're going to look at these on our calculator. They're not arithmetic. They're not geometric. So let me fire my calculator up. And then I'm going to show you how we type these in and what we're looking for. I'm going to clear all that out of there. So guys, follow through with your calculator on this. Our screens might look a little bit different, but we'll be able to tell at the end. So I'm going to try to figure out if the sequence 3 over n converges or diverges. The series 3 over n. My first number would be 3. My second number would be 3/2, and then 1. So to tell, here's what we're going to do. So if you would, guys, hit your second and then your stat button. Come over to math and come down to the word sum. And then go second stat. Come over to operations and down to sequence. Here's what we've done so far. We've just told our calculator that we are going to add up a sequence that we're going to type into the calculator. Now, our formula is going to wind up looking like this. My screen went to here. If yours goes to here, that's okay. If yours goes there, we're good. So in the expression, you type in the expression that we're looking at. In my case, it's 3 divided by x. Now, the variable will always be x for us. The start value will also be 1. Now, the end value is where we're going to play just a little bit. I'm going to ask you guys to use two values for me. I'm going to ask you to look at the 500th term and the 999th term. So we're going to go to 500. The step 1 just means, what do you want me to count by? Now, I'm going to hit paste just so you can see what it looks like if you have to type this out normally. You would still do the sum and the sequence, but here's what it looks like. There's the word sum, there's the sequence. Notice the 3 over x, there's my formula. X is the variable, comma, 1, that's what we're going to start with. That 500 is what we're going to end at. And we're going to tell our calculator count by ones. Now guys, this is really cool once I hit enter. What my calculator just did is plugged in 1, 2, 3, 4, 5, 6 all the way to 500, and it told me the answer is about 20.38. So I'm going to come over here and I'm going to say the sum of the first 500 numbers was about 20.38. Now on these, always round up. Now, a couple of ways to do this now. What I'm going to do in my calculator is I'm going to go second entry, and I'm going to come back and change that 500 to 999. Why 999? That's the last number that your calculator can handle. Let's hit enter, enter. Make sure you get this number too. It takes just a second. And notice that it's 22.45. Now, I'm going to say that the sum of these 999 numbers happen to be about 22.45. Now, since these are not close, they're kind of close, but you'll see what I mean by close on my next example. We're going to say that this series is divergent. It's going to grow forever. After we do number 26, you'll see what I mean if they're close. So let's go ahead and jump on 26 while I might have you a little bit confused. Here's what 26 would look like. It's going to be one of those, let's use our calculator because it's not arithmetic, it's not geometric. So it's going to look like this. Let me clear off my calculator for you, and we'll go through those steps again. We're going to go second stat, over to math, down to the word sum, second stat, operations, down to sequence. Now, I'm going to type in 11 divided by x squared. There's my formula. My variable is still going to be x. I'm going to start at 1. I'm going to end it at 500. Let's just go 500 and 999 every time. And then there we go. It's going to take a second for it to think. Oh, it would think a little quicker if I hit enter, wouldn't it? Now, round up on these. Don't round down because I know my sum is at least 18.07. So the sum of the first 500 is about 18.08. Now, let's come in and look at the 999 then. So I'm going to go second entry, and I'm just going to backtrack and change that 999. I'm at that 500 to 999. Let me go ahead and hit enter for you. You'll see here in a second when that shows up, they're going to be very, very close. 18.083. So the sum of the first 999 happened to be about 18.083. So we'll say that this thing converges, and it's going to converge to about 18.09, or if we round it to the nearest tenth, about 18.1. So a little bit of calculator work for you. Guys, my last one is I want to make sure you know how to insert geometric sequences. Kind of a common practice is guess and check, but let's avoid that. Since we know this is geometric, and that should be the word sequence, not the word series, because there's no plus signs, it's going to look like this. I'm going to use g sub n equal g sub 1 times r to the n minus 1, and let's plug in everything that we know. Some little things that I know. I know that g sub n is 12.20703.125. G sub 1 is 4. We don't know our r value. That's what we're looking for. N is the number of terms that I'm using. 1, 2, 3, 4, 5, 6 minus 1 is 5. Now, to solve this, it's going to look like this. Let me clear all that out. Let me type in my 12.20703.125. To solve this, I need to divide by 4. So that I got r to the 5th by itself. Do not round. Leave all those numbers on your calculator. To get rid of this 5th power, I need to raise both sides to the 1/5 power, the reciprocal power. And that tells me what my r value is. My r value in this case is 1.25. Now to fill in the blanks, let's go 4 enter times 1.5. There's my second term. So there's my third term. There's my fourth term. My fifth term. Did I mess up somewhere? Nope, I didn't. So guys, there goes our lesson. Good luck to you. We will have Zoom conferences coming in if we have any questions.